I think we can start now. Okay, that's been welcome. This is the second part of the review for the midterm 2. Okay, that's mean I will try to go through all of the concepts that were covered from the section 11.2 to the end, almost the end of the chapter 11, which is 11.7 for us at the moment, because we will still have few sections in chapter 11 after midterm 2. Okay, that's been 11.2 to 11.7. Okay, I hope you had nice productive session yesterday. Okay, and then let's see what we will have today. That means today we will focus mainly on infinite series. That we have to know what test to use in order to determine convergence or divergence. That means that's the main task for us. Just before I start, you can probably see, I don't know if you see my pointer or you can see now, the test will be open actually tomorrow, okay, which is actually today midnight. It's open Thursday, October 25th, and will stay open until Monday, October 29th, like as our normal weekly assignments. Okay? That means make sure that you have your appointment booked on Examity, okay? Because the last minute booking is not really recommended and creates lots of problems and stress. Okay? And as always, I check the appointments, and almost everybody have an appointment. That means that's good. That's the good sign. Okay, that means let's start. Infinite series. What I have a few, and I don't have many questions, okay? That means I have just the important one to cover the important concept. And as always, I really recommend to do all of the problems from Practice with Kasia videos and also from my weekly sessions. Because most of the weekly sessions, they contains really important questions. Right? And especially when it's multiple choice, or especially when I make a comment, oh, this is an exam type question. Right? That means you can get back to all of these weekly sessions and just pick the problems and try to solve it. Also, doing a sample problems, it's really good test. If you can print a sample test, let's say sample A, if you will have, I don't know, empty desk, empty room, no phones, no electronics, you can try to time yourself 90 minutes, 100 minutes, and try to take the test. Yeah? And then afterwards, you can check against the solution provided for you, and this will be a quite realistic score. Yes, quite good indication of your readiness. And then, of course, you can practice because we still have time. Okay, let's start. No more announcement and no more suggestion. If you have any question, you may use the chat box, always. Okay, that's me. My question number 1 is this one. If infinite series A sub n equals to 1, then find the limit. And the limit is at infinity of the expression natural log A sub n plus 2 all over the quantity 3 minus A sub n. That means, what do you think? Do you think you can give me the answer? It's quite nice and quick question if we know the concept. That means, what do you think? Which answer is good? I can give you a few seconds. A. Okay, Jessie's answering A. Would be nice to have more, to confirm that. Okay, you can try to answer. If not, okay, we can go from them. Okay, Andrea is saying D. Okay, interesting. That means I can tell you one of the options, A or D, is correct. And of course, D is not a correct answer, right? Because we remember the property. I can write this down for you. That one, theoretically doesn't mean the one itself, we're not using this information. We just using this, reading this, that this infinite series is convergent. Okay, convergent. And I can have 1, I can have 10, I can have 5, 6, 7. Okay, I can have any number. That means the number 1 doesn't mean anything. Just, I mean, it means a lot, but the 1 itself, we're not using this. This means that the infinite, actually, I should say this, that infinite series, A sub n, it's convergent. Okay, that's the information. And we know that if infinite series is convergent, the limit at infinity of the sequence A sub n, it's always 0. Always 0. That means, please remember, if we have convergence, always 0. That means this limit should be recognized as a ln 0 plus 2, 3 minus 0. Okay, that means ln of 2 over 3. Please do not use that 1. Okay, we will definitely ask this question because this theorem, it's extremely important. And that's means, please remember, I can possibly use different color. That's the property that we will be using. If the infinite series is convergent, then it's 0. Yes, thank you, Andrea. No problem. It's relatively easy concept, but of course, if we know what we're looking at, that we do not use that 1 now. Okay, that means the correct answer was yes, A. It is A. How can I can box the entire answer. Okay, let's keep moving. That means definitely question like that. And you can still check section 11.2 for more problems, but definitely, okay, definitely this theorem. Okay, let's keep working. Now, another question. That means now I will have like a mix of all of the types of infinite series, okay? And we have to know how to recognize them and how to test them. Okay, which of the following is true for the 4 series given below? And we have 4 of them. And we can see the options. We're just looking for convergence or divergence. No absolute convergence at the moment or condition. Okay, first one. The infinite series from 1 to infinity, 1 over n to the power of 3/2. What do you think? Is this infinite series convergent or divergent? Yeah, we should look at this and we should know right away. The p-value, it's greater than 1. That means this one is definitely convergent. Okay, nothing to do, no, like just by looking. Okay, what about the second one? P is actually less than 1 and it's divergent. Yeah, probably by now everybody can see this. Okay, what about the third one? Can you see right away that it's divergent? I hope so. Yeah. And now how can we prove? We have two tests that we can apply. What I can do? Let's go here. Okay. I can say that this is 3 over 2 to the power of n, which is the geometric one. Okay? The common ratio is the quantity taken to the power of n, which is 3/2, and it's greater than 1. If the common ratio is greater than 1, the infinite series is divergent, okay, by the geometric property. The geometric series. Okay? That means it's definitely divergent. Or, as always, we can try to use the test for divergence. Test for divergence is telling me that I have to find a limit, and limit at infinity of this sequence is 3 to the n over 2 to the n. Numerator is winning, it's infinity. That means also we can say that it's divergent by the geometric one or by test for divergence, because we've got infinity, the limit, okay? That's we can see that it's definitely divergent. Okay, and now what about the last one? Do you think you can tell me -1 to the n, -1 to the n over n to the power of 2/3? That means what test we can use, and probably Okay. No, okay, I can, yeah. I of course, I wanted to ask you the question, but also I'm at that point, I'm really hoping that everybody can say that this is convergent. Okay, because we can see alternate, we can see -1 to the n, then I can use AST, alternating series test, and alternating series test is telling me that I have to pull out the formula B sub n, which is just 1 over n to the power of 2/3, everything except the alternating part. And now we have to test. This is definitely positive. Limit of B sub n at infinity is definitely 0. We can see this. And B sub n, since the denominator is increasing, the whole fraction, the whole term is decreasing. That means since I'm satisfying all of these conditions, I can say this infinite series is convergent by AST. I can make the conclusion here. Okay? That's when we can see, that's how we can test. And make sure that you see the difference between number 2 and number 4. Because number 2 is not alternating one. It's simply the integral test or the P series test. It's divergent because n is taken to the power of the number less than 1. This one looks almost the same. However, we do have the alternation. That means when we alternating, we adding, subtracting, we checking all of these 3 hypotheses, we satisfying them, and then we can say it's convergent. Okay, that will make sure that you can recognize. They are really, I like the list of these infinite series. It's nice combination. Okay, and now we have to just pick the answer after all of that work. Number 1 and number 4. 1 and 4 are convergent. Okay, that means these two are divergent. Okay, good. Again, you may ask any question. Okay, let's keep moving. Now I have true and false. Okay? Because we will probably ask you like a short questions, true and false, but we will create like, they will be not worth like the 5 points, okay? Like maybe 3 points, but we will also ask you a true and false question. Okay, that's what we have. If a sub n equals to f of n, that we have a corresponding function where f of x is, of course, positive, continuous, and decreasing. Positive, continuous, decreasing. We remember that's the condition for the integral test. Then the corresponding integral from 1 to infinity f of x dx equals to 4. Okay, that's what we did. Compute the integral, evaluated integral, we got 4. Then the corresponding series is also 4. That's what do you think? Is this true? If I am using my integral test and I'm integrating a function and I'm saying that the corresponding series has the same value. If, of course, if this is convergent, because it is convergent. That means, do you think this is true? That's what they're asking. Of course, it's not. Because if you remember in the integral test, we can compare. That means if this is convergent, this will be also convergent, but I don't know, the sum could be a little bit lower or a little bit bigger. Depends what the other conditions. That means this is never the same. Okay? Please remember that. We like also ask this question, okay? But the integral is never the same like the infinite series. They means almost the same, but you probably remember the proof, like some of the rectangles, if we divide the area under the curve, because that's the definite integral, that's the definition. Some of the rectangles, they were like sticking outside the curve or below. That means it never corresponds exactly, but it's comparable. We can compare. That means please remember, they are not the same, but we can definitely use this as a tool. That's our test actually. Okay, now let's look at this one. I think this is false. What about this one? If the limit of the sequence a sub n at infinity is 0, then the infinite series is convergent. What do you think? Is this true? Of course it's not. Okay, because you can always think about this. Limit of 1 over n, it is 0. However, my infinite series 1 over n, which we even have a nice name, harmonic, it's actually divergent. Okay? Divergent is the harmonic series. Okay? That's it. Please remember, if the limit is 0, we know nothing about convergence. We may have convergent, but we may also have divergent. That's when this statement is definitely false. Okay, definitely false. The other way, like shall I come back? This one. If the limit, if the infinite series is convergent, which of course we have to test this somehow, like we have to use, but if we definitely know, like for example this, if the infinite series is convergent, then the limit always is 0. Oh yes, then we have no option. The terms, they have to get smaller and smaller and smaller in order to have a chance for convergence, but not the other way. If the limit is 0, we know nothing. We can't conclude convergence. Okay, that's me, please. Okay, remember these properties. Okay, and then, okay, that's me. This is the true and false. Don't miss these true and false because they are typical true and false questions. Okay, now let's start. I will have a list of the infinite series and we have to check convergence and divergence and later absolute convergence and conditional convergence. Okay, what we have? We have summation from 1 to infinity, negative 1 to the n plus 2 to the n over 4 to the n plus 1. That means, what do you think? What type is this? How can I bite? How can I start working on that? Of course, we do see the addition, which can really mislead us. But what the other thing, what I see n placed in the exponent only. That means I will rewrite this as a 2 infinite series, negative 1 to the n over denominator plus the other one. Okay? 2 to the n and 4 to the n plus 1. Okay, that means now definitely I have the sum of 2 geometric series. That means they are geometric one. That means the test, I'm just using the geometric series. And let's see, let's investigate the first one. We need a common ratio. Common ratio is the quantity taken to the power of n, which I see negative 1 and I see 4, which will be negative 1 over 4. This is actually between negative 1 and 1. That means infinite series is convergent because the common ratio is between negative 1 and 1. If it's convergent, I can use the sum. A1 minus the common ratio. Let's try. The first term, okay, let's work it here. The first term is simply the whole quantity taken to the power of that number, which is 1. We have to always focus. If it's 1, we have to substitute 1. If this will be 0, for example, then I have to substitute 0 to create a first term, but it's 1. Negative 1 to the 1 is 1. 4 to the power of 1 plus 1. That means the first term is negative 1 and 4 to the power of 2 is 16. Negative 1 over 16, 1 minus negative 1/4. Okay. Actually, the question is not even asking for the sum. Okay? The question is asking if it's convergent. But let me get the sum because this is a typical question that we will probably list numbers, like all of the options, and the numbers will represent the sum. That we have to still do the arithmetic. And of course, the formula. Okay, what I have negative 1 over 16 and 1 plus 1/4, which will be 5 over 4. if I flip the number, I will have negative 1 over 20. Oh, I don't, no, something is wrong. I'm trying to be fast. Negative 1 over 16 times 4 over 5. Actually, it was correct, because dividing by fraction, 5 over 4, means multiplying by the reciprocal, and 4 and 16 I can cancel out. 4 times 5, it's 20. I can write down just to save negative 1 over 20, okay? And then we do have the other one. Let's work it out. I can maybe use that space. Common ratio is 2 taken to the power of n and 4. 2 over 4, which is 1/2. And the same is between the interval from negative 1 to 1. It is convergent. That means if I will have this question, I can simply say converges. The infinite series converges, but I can, since it's the geometric one, I can find the sum. Converges to S, and let's work it out. Oh, I need the first term. The first term will be 2 to the power of 1 and 4 to the power of 2, 16. 1 over 8. That means I need 1 over 8, 1 minus half. That's a little bit easier. 1/2, 1/4. Because 1/8 divided by 1/2 means 1/8 multiplied by 2, 1/4. Okay, and then what I have to do, I have to add these two numbers together. Negative 1 over 20 and 1/4. Okay, I'm adding them together. Negative 120 plus 1 over 4, which is negative 1 plus 5 over 20. Am I right? 5 over 20 is 1/4. 4 over 20, which is actually 1/5. The sum is 1/5. I can squeeze here. Okay. That means what I did, I proved that it's convergent. I did recognize that it's the summation of two geometric series. That means please do the same thing. And as I said, probably for this type, we will have the options. We will have the summation for you provided. And you have to say, if it is convergent, we have to compute the sum. That we make sure that you know this. I mean, that's the formula. And of course, the common ratio must be between negative 1 and 1. That's the condition for convergence. Okay, we good with the geometric one. Let's see my next one. Okay, infinite series from 1 to infinity, 1 over n times n plus 1. Okay, that's what we have. It's not a perfect form of this infinite series, but since I see n and I see another part n plus 1, I can definitely think about the telescopic series, because what I can see, I can definitely rewrite this. I can do the partial fraction decomposition, a over n and b over n plus 1. But I have to find a and b. Okay? And we remember the numerator 1 must be the same like this numerator with the common denominator. That means a will be multiplied by n plus 1 and b will be multiplied by n. N plus 1 and b times n. And then when I substitute for n 0, let's say, then my equation is 1, this is gone, a. Okay, that means a is 1, and if I substitute for n, of course, negative 1, my left-hand side didn't change, and this is negative b. b is negative 1. Okay, that we do have extra algebra, but that's okay. 1 over n minus 1 over n plus 1. Excellent. Now I can definitely, because that's the friendly form, I see the difference of two terms which came from the same sequence. 1 over n plus 1, 1 over n plus 2, and so on. Yeah? That means this is definitely the telescoping one. For the telescoping, it's a little bit time consuming, but as soon as you practice, it's so easy. That means what we will have? We have to find the sum. The sum will be, let me change maybe, and I will replace with I. I from 1 to n. That we have to find like the partial sum, S sub n. Okay, that means this will be S sub n. And then I have to find the whole sum will be the behavior of S sub n at infinity. And we can try to find out. But first of all, let's find this. 1 over I plus 1. Okay, and I will rewrite. I will substitute for I1, 1 minus 1/2. Then I will substitute for I2, 1/2 minus 1/3. I will substitute for I3, 1/3 minus 1/4. And then I will skip, and I will also list a few terms on the back side. Let me indicate. I was 1, I is 2, I is 3. No, I don't want to do this. And then actually getting from the back side, I will be n, and then 1 less, n minus 1, n minus 2, and so on. But I will not list everything. Okay, let's start from the back side. Instead of I will put n. 1 over n plus 1. Instead of instead of I, n minus 1. N minus 1 plus 1 is just n, and then n minus 2, n minus 2 plus 1, n minus 1. And now let's see what's happened. We remember this method of difference. We have lots of cancellation because we have negative half, positive half, negative 1/3, positive 1/3. And this negative 1/4, I will definitely cancel if I will list more terms. And now let's go backwards. Positive, negative, and I will also cancel with some terms if I will list them. Okay? That means as soon as I did cancel both items in one term, this means that I will be canceling them like all over. And the same pattern will happen from the back side. I did cancel 2 items from that term. That means from now on, I will cancel all of them. But what I didn't cancel, 1 and this. And you remember, the pattern is the same. Since I didn't cancel the first quantity in the first term, I will not cancel the last quantity in the last term. That's kind of like a mirror image. Okay, that means what is the formula for S sub n? It's 1 minus this. Okay, and now we have to check how this behaves at infinity. That means this will be 1 minus 1 over n plus 1. And this goes, of course, to 0. 1 over infinity is 0. The final sum is 1. Again, I don't have to find the sum, but I mean I still have to determine whether the infinite series is convergent or divergent. That means it's definitely converges to 1. Okay, and what we use? The telescoping series. Jess is asking if we can use the direct comparison test. Actually, yes, we can use the direct comparison, and probably will be like a minute, which actually I can try to do it. But the thing is, I'm trying to think a little bit ahead, because if you will get this infinite series and we will ask you what is convergent to, that means I really want you to recognize that is telescoping, know the process, okay? Know how to find the partial sum and the limit of the partial sum. But yes, you're right, and we can try let's use different color. That means what we have, we do have infinite series, and I can say n squared plus n. I can try to compare with n squared, right? Because I'm picking the highest. Since this denominator is greater, the whole fraction is smaller. Wow, so easy, right? Because on my right-hand side, I have convergent, right? The infinite series is convergent. Everything what is smaller is convergent too. That means this one is convergent by direct comparison test. Yes, we can do. If we just need to know if it's convergent or divergent, we can do the blue test, the direct comparison, which actually I can say. But of course, direct comparison test will not tell me the sum. Okay. Also, actually, good. I can add a little bit of hint. If we asking you for the actual sum, like is like what is the infinite series is convergent and what is the sum, please remember it's gonna be only telescoping series or geometric one, because that's the two types that we can actually compute the sum. Rest other tests are not really testing the actual sum, it's just testing the convergence or divergence in general way. Okay. But please also make sure that you know this telescoping procedure. But of course, that's the fastest way. Okay, let's keep working. But good, Jessie, that you can see this. That's also really important. Okay, yeah, this one. N over cube root of n to the power of 4 plus 1. Right, definitely this one I will try to compare because it's not a telescoping. That means in order to compare, we always trying to keep the highest, the leading functions. And let's simplify this one first. This will be n. This will be n to the power of 4 over 3. And this is 1. 1 minus 4 over 3 is negative 1/3, which this will give me that. Okay, that's mean comparing to the leading, right? Am I right? 1 minus 4 over 3 is negative 1/3. In the denominator is positive. Okay, that's what I see. I see that this infinite series is definitely divergent. Divergent, okay. Now, let's compare the terms. Just looking at the fraction. That means this fraction, the difference is just plus 1 in the denominator. If the denominator is bigger, the whole fraction is smaller. Right? That means this, it's smaller than this. And if my infinite series on the right-hand side is divergent, which means huge, right? Infinity, then something that is smaller, I don't know. Because smaller than divergent could be actually convergent. That means I can't really use direct comparison test with this one, doesn't work. Okay, with 1 over n, yeah, it's not working. Let me use different color. That means please remember we can't use it, but what we do have a limit comparison. That means let's try. I will try to compute a limit of a sub n over b sub n. And we know what's that means a sub n is the original one. N cube root n to the power of 4 plus 1, and dividing by b sub n. B sub n is this one, of course. That's my b sub n. I will multiply by the reciprocal. Okay, let's look at the degrees of the function. N to the power of 1 and n to the power of 1/3 will give me 4/3. That's n. And this one, it's the same actually. And then we have the other terms. But the degree is identical. The leading coefficients are 1. The ratio is 1. And for the limit comparison, I'm just looking for the positive finite number. Okay? That means since I'm getting positive finite number, both of them A sub n and B sub n behaves the same. I can say that my infinite series diverges by limit comparison test with 1 over n to the power of 1/3. That's what we were comparing. That means since this one is divergent and the limit works, then the original one diverges too. Okay? But please remember, direct doesn't work. We can't conclude, we can't compare when we have this relation with the divergence. Okay? Let's see next one. The infinite series 2 plus cosine of n over e to the n. What do you think? Maybe you can tell me. Probably you can tell me right away. Do you think it's convergent or divergent? Converges or diverges? Oh, it's convergent, of course. It's converges, and this one, it's really good to, we remember, as soon as we see cosine or sine, we know that maximum value of cosine of n, it's 1. That means cosine is always less or equal to 1. That's what I can do. And now I see really nice summation, 3 over e to the power of n. This one is the geometric one because n is placed in the exponent only. Common ratio, it's only 1 over e because only e is taken to the power of n and it's placed in the denominator. This is less than 1. That means this one is convergent. And we don't even have to find the sum. Convergent by the geometric. Okay, now everything what is smaller, it's convergent by direct comparison. By direct comparison test with, but please remember, put that 3. Because if the 3 is not there, we can't really compare. And of course, all of the terms are positive too. That means by direct comparison test with this one. Okay? That means we're using direct comparison test. Please do not put the geometric because this is not convergent by the geometric, by comparison with the geometric. Okay, Sandy has a question. I thought geometric had to have n as all, Sandy, I don't know if I understand the question, but yes, n must be placed in the exponent only. Okay, that means this is, oh no, this is just, oh no. If we will have additional n, that will be the problem, like let's say 3n, that's not a geometric. But n, my only n that I can see is only in the exponent. That means I can maybe rewrite this as a 3, like that, if you wish. That's the same thing. That's e. Right? That we can see when looking at the formula, n is only in the exponent. We don't have to have n everywhere. Oh, no. We have to have n in the exponent only, and we do have. Yes, exactly. Yes, must be in the, we don't have to apply, we don't have to see everywhere, but only in the exponent, yeah? Okay. That means this one is typical geometric, really nice geometric. Okay, but one more time, this one is not the geometric, we're comparing with the geometric. Okay, good. What about this one? Let's start with 3. The summation, the infinite series from 3 to infinity, -1 to the n over ln of n, natural log of n. Can you tell me right away if it's convergent or divergent? I'm sure you know, because we looking at the alternation part, I think I can use AST. I can definitely, actually we have to be careful because AST is testing convergence only, right? We can't conclude divergence. But let's see. The B sub n formula, it's just ln of n, everything except -1 to the n. and we can test. B sub n, which is ln of n, is definitely positive. Limit at infinity of ln of n, of course, is 0. And since denominator is only getting bigger, the whole fraction is getting smaller. That means this is decreasing. Decreasing. Okay, check, check, check. The infinite series, the alternating one, -1 to the n over ln of n, it's convergent. Convergent by alternating series test, AST. Yeah, like I just said few seconds ago, please remember AST is only testing convergence. We cannot say that the infinite series is divergent by AST. No, that means if we're not satisfying, you can see check, check, check. If something is wrong, then we can't use AST. Please remember, we can't say divergent. No, we can only say convergent by AST. On the other, is the same thing like the test for divergence. We can't use test for divergence and conclude convergence. Okay, makes sense. Because sometimes you will tell me, oh, it's convergent by the test for divergence. No, 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 no. Okay, that means test for divergence is only testing divergence. Alternating series test is only testing convergence. Yep. If something is wrong with this, just throw it away and use the other test. Okay, now let's look at this question. I will also change. Now it's the same formula, but now I'm asking if this infinite series is absolutely convergent, conditionally convergent, or divergent. That means what we just did, let me switch the slide for a moment. I just took this formula and I tested like it is. And we can see we do have convergence. Yeah, that's me now, absolute, okay, Sandy, probably we can check. That's me now, I will try to check absolute convergence. I have to take absolute value. And let's see what we have. Absolute value of ln of n, it's still ln of n, but -1 to the n will become just 1. Okay? ln 1 over ln of n. And now, of course, I can't use the AST is gone. That's not my test anymore because I don't have the alternating part. Okay, I will try to compare. Okay, I will compare 1 over ln of n, maybe with 1 over n. We know that function ln of n, I can even draw it, that's natural log of n, okay, and that's just n. This is n, this is ln of n. That means n is definitely bigger, okay? That means if the denominator is bigger, the whole fraction is smaller. Or the other way, if the denominator is smaller, the whole fraction is bigger. That means I do have my relation. This one is definitely divergent. Infinite series divergent. Everything what is bigger is divergent. I can say by direct comparison test with harmonic one, 1 over n, actually, I can keep 3, doesn't matter, but it matters for the natural log. By direct comparison test with 1 over n, this infinite series divergent. Actually, I can say here, divergent by direct comparison test. Okay, because direct comparison test works. That means what is the final answer? Absolute value is not giving me convergence. Okay, that means it's not absolutely convergent. Okay, it's not absolutely convergent. That means what we have to do, since it's not absolutely convergent, I have to theoretically remove the absolute value and test the original formula, which I did on this side. and I'm getting convergence. And let me put absolute value because we were testing. That means, what do you think? What is the final answer? It's not absolutely convergent, but the original formula is convergent. Yes, thank you. This means is conditionally convergent. Probably that's the condition, -1 to the n. The alternating part is giving me this condition that actually I'm getting convergence. That means not absolutely, but convergent. Our terminology is conditionally convergent. Okay. Also good example, really good. Okay. Determine whether the series is absolutely convergent, conditionally convergent, or divergent. 5 to the n, n plus 1, n factorial. That means, what do you think? What test we can use? You should recognize right away. If we have a combination of few different types of expressions, related rates, no, I don't know. Ratio, yes, I don't know if Sandy means ratio, but ratio test. Because what we have exponential, 5 to the n. We have just n, algebraic, yes. And we have factorial. That means ratio test is the best. Okay, let's try. Ratio test. Ratio, limit of the ratio, a sub n plus 1 over a sub n, absolute value. All of the terms are positive, then I'm gonna ignore the absolute value. Okay, 5 to the power of n plus 1. N plus 1 in n plus 1, it will be n plus 2. And n plus 1 factorial. And dividing by a sub n, I will multiply by the reciprocal. Okay, I can keep absolute value for now, but I will skip with the next term. Okay, that we do have 5 to the power of n, 5 to the power of 1, n plus 2, and n factorial. And I have 5 to the power of n, n plus 1. And n plus 1 factorial, we all know that I can rewrite as a n factorial times n plus 1. And let's simplify. And what's left? Limit at infinity. 5, n plus 2, and then n plus 1, and n plus 1. Okay, that means I see n to the power of 1, and I see n squared in the denominator. Denominator is winning, the whole fraction will be 0 at infinity. 0 is a good number because 0 is less than 1. That means this infinite series absolutely convergent by ratio test. Oh, by the ratio test. That means, please remember, lots of different parts, always ratio is a good test. And it's testing absolute convergence right away. Okay? Infinite series from 1 to infinity, -1 to the n, n to the power of 2n, all over 3n squared plus 1 to the power of n. That means, what do you think? What test will be good for that formula? You can see this is taken to the power of n, and this is taken to the power of n. Oh, not even mention this. But this one I can ignore because we will take absolute value. That means I can rewrite -1 to the n, n squared, 3n squared plus 1, and everything is taken to the power of n. Right? 2 times n will be 2n, and this will be taken to the power of n. That we remember, if the entire formula is taken to the power of n, then it's the root test is good. Right? Because of that. How can I say? Because of that. That means let's try. Root test is telling me that I have to take the nth root of entire formula. Okay? Nth root, and absolute value, we will kind of ignore the -1 to the n. Okay? That means I will not write the absolute value. Oh, am I erasing everything? I will just put n squared 3n squared plus 1, everything to the power of n. And I'm skipping absolute value because everything is positive, and this is gone. And we can see the nth root and n, it's gone. Limit n squared, 3n squared plus 1. And what is this limit at infinity? Of course, is the functions are the same, just the ratio of the leading coefficients. 1/3, it's less than 1. Again, we have absolute convergence by the ratio test. Okay? But please remember, if the entire formula is taken to the power of n, use the root, not the ratio, root test. Use the root test. Okay? That's absolute value. Okay? What else I have? Oh, that's nice. What do you think? 1 plus 1 over n to the power of n. It's again the entire formula taken to the power of n. But you can probably see, if I will apply the root test, the nth root, this is gone, and this limit is 0, this is 1. That means we will get the limit 1. If the limit is 1 by the root test or ratio test, it's simply inconclusive. Okay, that's when we can't really use the root, and the ratio test will be, I mean especially root, because we're seeing this. The root test will be inconclusive because the limit will be 1. 1 is not telling me much. But what I can do, I can try simply to check the limit. Test for divergence. And do you remember what is this limit? You will definitely see this on the test, because I did solve this few times. If you will check my practice with Kasia, or even the weekly session, this limit is always. Of course, in order to to prove that limit, we have to go through the L'Hopital rule, the power form, and so on. But we know that this is E. Okay, we have to know that. Please remember, 1 plus 1 over n to the power of n. That's E. And even more, oh, it's my writing. Okay, let me put n and n, and we can add coefficients a and b. Then the answer is E to the power of AB. Okay, please remember, then you're not gonna miss this on the test. Okay, I think I have few limits like that in my, just for the sequence from the section 11.1. Okay, that means let's come back to my question, because that's actually, if the limit is different than 0, we do have divergence by test for divergence. The limit is E, which means at some point, yes, I will be adding the first term, I will be adding the second term, and so on. But at some point, I will be adding E plus E plus E, because at infinity, these terms looks like 2.71. Okay? That's the reason that is huge. If the limit is not 0, no chance for convergence, divergence. But please remember this limit. Okay, you will not regret. Okay, what else I have? Oh, looks actually similar, but I have to be really careful, because now I can kind of see n squared. Let me come back. That means you can see I don't have any n squared. Only n is giving me the E form, or some extra coefficients. That means what I will do, I will try to rewrite first 1 plus 1 over n. Maybe I can leave maybe like that, because negative n and n additional exponent, it will give me n times n is n squared. Okay? That's what I can do now, since I see that my entire formula is now, because now it's different, I mean it's taken to the power of n, I will try to use the root test. because I do have this additional n. That means let's try to, no, actually I like the red and I will cancel with the blue. The root test, we have to take the nth root of a sub n, absolute value, and find the limit at infinity of the nth root, and let me copy everything. Negative and actually everything. And that nth root and that n is gone. And what's left? Limit 1 plus 1 over n to the power of negative n. That we can see now, this limit is not just the original series. It's not like original sequence. Okay, it's actually after the root test, after the nth root. And do you think you can tell me what is this limit right away? We can see that negative e, oh, thank you, is e to the negative 1 or just 1 over e. Really good, really good. And this is actually fine. This number is less than 1. Okay, that you can see I'm making different conclusion. I'm not saying this limit is not 0. No, because I'm not using test for divergence. I'm using different tests. This limit is less than 1 by the root test. It's absolute convergence. Okay, by the root test. That's what we make. Yes, make sure that you see the small differences. Yeah, nice actually limit. Let me show you just one thing. If we will ask you limit like that, okay, that means make sure that you will do this because it's kind of like similar, but it's still, yes, it's still not, I can't see the e value. But what I will do, I will flip the numbers in the denominator, I mean in the parentheses, and put negative, as we can see, and then I can say n over n is 1, 1 over n will stay 1 over n. And now we can see that that's the answer. Just in case if you will have something different and will look like that, make sure that you know that step. Okay, like with this negative, because we're flipping a fraction. Okay. And then, of course, we can make different conclusions, depends what we're looking at. Okay, and I think this is my last question. That's when you can see I pick like important types of infinite series of different formulas, and just we did apply almost all of the tests. Okay, make sure that you check section 11.7 for the summary of the tests, because I did create like a reference page for you, and you have, it's just one page and contains all of the tests. Okay, but now let's finish the session with this question. Consider the alternating series, -1 to the n, 16 over n to the power of 4. From the list of the numbers given below, choose the least number of terms necessary to ensure that the difference between the actual sum and the nth partial sum as sub n is less or equal to 1 over 10 to the power of 4. As we remember the alternating series estimation theorem, that the difference, okay, between the actual sum, which of course we don't have the sum, and the partial sum for the convergent alternating series is always less or equal to the next like missing term, because S sub n will only include the terms up to B sub n. That means we know, because I'm not going to prove this theorem, but we know that the error, in the approximation, it's always less than that term, always the next term. And of course, looking at this infinite series, it's definitely convergent, because the formula B sub n, it's 16 over n to the power of 4. It's positive, limit 0, and is positive, limit is 0, and it's decreasing. Okay, I don't want to prove this limit of b sub n at infinity is 0. That means it's definitely positive, limit 0 decreasing. Okay, that means now we can see how many terms we have to take for this term to be less than or equal to 1 over 10 to the power of 4. That means the easiest way is to simply start making a list of all of the terms. That means if I will create b sub 1, but b sub 1 is funny because it's just 1, which is 16. It's way too big. Let me put that number because that's the number. Okay, b sub 2 will be 16 and 2 to the power of 4, which is 16. It's 1, way too big than this one. But now, let me stop because, of course, I'm not gonna like put b sub 3, b sub 4, b sub 5 because all of the terms are gonna be greater. But what I'm looking at for the smaller. I'm looking for the term, the first, yes, the least number, the first available term that is less than 1 over 10,000. But what is my point? My point is to look at these options, right? That means since they list like 10 terms, 20, 40, 80, 100, then we don't have 1, 2, 3, 4. That means I can probably test this number first. That means let me skip and let's check b to the power of 10. I mean b sub 10, the 10th term. 16, 10 to the power of 4, which is 16. Okay, that means I see the denominators are the same, but 16 is greater. Okay, that means that's still not good. Now let's skip and let's try 20. 16, 20 to the power of 4. 16, 20 to the power of 4 is 2 to the power of 4 and 10, 4. And 10 to the power of 4. 2 to the power of 4 is 16 and 10 to the power of 4 is 1 and 4 zeros. And I can see that actually my term is identical like the error. And they said actually we can try to because they said equal to. Okay, that means what's happened. The B20th, the 20th term is exactly the same like the desired error. Okay, and then what we can do. The least number of terms necessary to ensure that the difference is less than this will be always one number less than this one. Yeah? Because we can see 20, let me use different color. You probably know this from my other practice. 20, because 20 works for us. That means 20 means this number. Okay, and b sub n plus 1, and we've got 20. That means if 20 is n plus 1, n is simply 19. That means 19 is the least number of terms, like to ensure that the difference between partial sum and the actual sum will be less than or equal to that number, 1 over 10,000. And of course, if I will keep working like b sub 21, b sub 22, I will always get terms less than this one. That means any number greater than or equal to 19 is correct. Yeah? Because of course, makes sense. If I add even more terms, the error will be smaller and smaller and smaller. That means what, like just general, like of course we do have the option and we have to pick the answer, but I'm just telling you that 19 is the smallest number. And if 19 will be on that list, we have to pick 19. But since 19 is not, 20 is the correct answer for us. But I can tell you, if this will be not here, all of the options are correct. Because makes sense, common sense. When I'm adding more terms, I'm even making my error smaller. But since they're asking for the least, the smallest number of terms, 19 is not placed, 20 is the answer. But because what I would like you to, no, I'm not picking 20 because of that 20. No. If this will be 19, I will of course pick 19. Okay, that we have to make sure what if we understand, because the term that we're investigating is n plus 1. It's n plus 1. Okay, that means 20 is actually 19 plus 1. N is 19. Okay, we do have questions. So 20 is not actually the correct answer. It's the best answer of yes, correct? As I said, 19. So 19 is the correct answer, like overall, if I will not have options. But 20 is the best available answer. Really good. It's nicely said. Yeah. But I just want like you to understand. And we can, for this type of question, please just play with the terms. Okay? And look at the term that is, as soon as you find equal to or less, that's the number. And always make sure that you're making one less because it's n plus 1. Yeah. Okay, that means that's all of my questions. If you have some questions, I can answer. If not, we can still, of course, use the discussion board. Like probably over the weekend, we have to be a little bit quiet. And, you can still ask the question. But as soon as you take the test, do not ask any midterm exam question. Okay, the exact questions do not ask on the discussion board. You can email me and I can give you some feedback, but do not ask the exam type question on the discussion board. You can ask your questions, which I will still monitor and answer, but as I said, do not ask any exam type question. Okay, thank you very much for joining me, and thank you for joining me for this review session today. And good luck. Actually, I was gonna stop the video. Good luck at your test.